Hello lovely people, another sunny day in the UK. Today we will be playing with some recoil gear. If you are following me on Facebook or if you are a member of 12 Volt Clean Wiring Club, probably you've seen this. This is an amp rack that I made for these two recoil amplifiers, and I decided to add the Down for Sound DSP because this is supposed to be like a budget kit. I didn't want to add the Helix just because of the price differences. This Down for Sound Easy DSP is probably the best budget DSP that you can get now. I'm not sure about all the politics, what's happening in the US with tariffs and everything, but if you have this for the current price of $360 or something, grab it, because if everything is gonna go in the direction that is going, this DSP is gonna cost the same as the Helix in a couple of weeks. So this DSP, 12 channels, way too many that we need. We have this monoblock Recoil Red 1200.1, and we have a small 4-channel DI550.4. So this is all done. The only thing that I have left is to connect everything. So I need to run the power, remote, coax from the head unit, and speaker wires out into the front. And in regards to the speakers, we will be playing with these. So if you remember, I got these from Recoil for a review. So I will approach this review in a slightly different way that I usually do. What I usually do is I do all the objective measurements first and then test them in the car. However, I have only a few hours today and next week is going to be very busy. So what I want to do is I want to break them in, but break them in properly. So I will put one set in the car today. You're going to be with me, you're going to see that, and we're going to connect everything from this. I will be running not really active, semi-active, kind of passive you want to say, because I have 4 channels on that amplifier and we're going to have 4 speakers. So it's going to be in the front doors and in the rear doors. So in this video, we will cover kind of back to basic style, what is the difference between a coax driver and a component driver. We're going to install it. I'm going to show you how I do that. I'm going to be using these rings, aluminum rings, for the rear doors, because in the rears, if you watch my deadening video, I have nothing. It's a blank plate and everything is covered with deadener. We'll be putting these rings and the speakers, then I'm going to make all the connections and we're going to measure them in the car as they are, and we can see what can we do if we have a very basic system where we have 4 speakers and the components, which are components, these ones components, and are going to be run on passive crossovers. So let's start with that. Let me open these and let's talk about components versus coax drivers. Here I have all the drivers unpacked. So what is the difference between a component speaker and a coaxial speaker? The main, and in most cases the only difference, is where the tweeter and how it is mounted. Component speaker is a set of 2 components, which is your mid-range or mid-bass driver and a tweeter. They do have usually a passive crossover in between them, but it's 2 separate speakers that you mount in 2 separate locations. Coaxial driver, it means that it uses the same axis for both drivers. So it's usually the speaker's pole vent where the voice calls of both speakers kind of align on the same axis. And typically coax drivers cannot be taken apart. You have like a whole assembly of the woofer, mid-range or mid-bass, and the tweeter in one. Now you do have some coax drivers that can be kind of converted into components, or you have this center piece like that, it unscrews, or you have a screw from the back and you can take it out and maybe put like a bullet style face plug in there, and you can use that tweeter to mount somewhere on the door or on the pillar. So those are kind of universal, and you can use either coax, either component with the same drivers. Now if we're talking about a frequency range that these speakers are playing, if you take the whole set, and the whole set is going to be the same. The main kind of concern is the very top end. Do they play all the way up to 20 kilohertz, as everybody says in hi-fi should be 20 to 20. So the tweeters on both of them should play up to 20. The woofer itself, usually 6.5 woofers, they do have problems above like 1.5 kilohertz. Some of them can play a little bit higher, but due to car acoustics and everything we're going to show you, you might have some problems. And tweeters kind of pick up from there. And it's exactly the same with these drivers, just everything is all in one. So the woofer is playing up to 1, 2, 3 kilohertz, and then the smaller tweeter kind of picks up. Now, the gripe that I have with coax speakers is that most of the time, not always, not 100% of the time, but most of the time, a coax driver is going to be inferior to a component set, just because when you have a driver that incorporates both the woofer and the tweeter into one assembly, you will have some compromises made in the design and in the production of the driver. And a lot of times the tweeter is the thing that suffers the most, because when you think about it, like this is you can see it's extremely tiny tweeter, especially this one. It's tiny baby tweeter, so it cannot play low at all, and you're not going to have a lot of output from it. So even in a component set, if you're going to compare the size difference between this and that tweeter, the difference is massive. And the bigger the tweeter, the lower it plays, and the louder it can play without any distortion. So again, most of the time, not always, coax driver is going to be a compromise, and that's why I would not recommend buying them at all. This is like talking from a SKU perspective. Now, obviously, if you want something extreme budget just to shove in the doors, yeah, it's like, why not? And especially if you don't have any factory locations for the tweeter, then yes, coax is going to be most of the time your only option. Now, talking about prices, these sets are extremely budget. I think these Echo series are going for like $30 to $50, so it's extreme budget stuff. And those, I think they're a bit more expensive, like $80 to $100. I think those supposed to be a bit higher tier. I'm not sure, because it's very difficult to find any information about Recoil stuff. So when I'm going to do all the measurements and review and everything, bear in mind the price, because these are really budget things. Now let's talk about the crossovers on components and coax drivers. Let's start with the coax because it's much easier. Every speaker should have some sort of a crossover. Woofers most of the time can play all the way up, and the crossover is going to be provided by the amplifier, because on the amplifier you can put a high pass crossover and remove all the bass from any of your drivers. You can do that exactly the same thing with the DSP, which is going to be much more accurate. So the high pass crossover for any woofer will be from your amplification, and it's not going to be on any passive network or on the driver. However, the high pass for the tweeter is going to be built into the whole assembly. Here you can see, if I'm going to find, there we go. These are the leads that go into the woofer, yeah? Here at the bottom, you can see the leads that are going into the tweeter. So they are connected in parallel, and they go through this boot, through the pole vent piece. You can see this indent where the cable goes, and it goes inside through that pole, and it comes out somewhere at the bottom, and it goes into the tweeter. This tweeter has a capacitor in line somewhere built in. On this one, I cannot show you, but on this one, if we're going to take it, it is right there. See that black little thing with white writing? This is a capacitor that blocks all the lower frequencies coming into the tweeter. Now, most of the time, judging by the size, probably is going to be something like maybe 4 microfarads or something. That's a typical value for tweeters, or maybe 2 microfarads if it's crossed a bit higher. And the crossover for this tweeter is going to be 4, 5, 6 kilohertz. So very high, because again, it's a small tweeter. And the slope, since it's a single capacitor, is going to be 6 dB. So 6 dB slope, about 6 kilohertz, depending on the impedance of the tweeter. We have a very similar situation with some components as well. Some components will have a passive crossover network, and some of them will have only this thing, which some people call a base blocker. It's basically just a single capacitor. This one looks bigger, so this is probably going to be a higher quality capacitor. Most of the times in these cheap sets, you're going to find a bipolar electrolytic capacitor, which is not ideal, but it does the job, and it's very cheap. So this is going to be, again, connected in line with your tweeter, and it's going to filter out all the lower frequency content so you wouldn't blow it. You cannot use a tweeter without any sort of passive crossover network unless you're going to run fully active and you set the crossover at the DSP. More elaborate passive crossovers are going to be something like like this. This is a two-way crossover network for this blue set. And if I'm gonna open it somehow, there we go. This has a bit more parts. You have your inputs, you have your tweeter output, and you have your woofer output. So with these, what's happening, you have two components per driver. So the woofer will have a low pass filter made out of a coil and a tweeter, probably is going to be these two, that are going to be chopping off the very top end where this mid-range blends into the tweeter. So it's going to chop off the high frequencies, because you want one driver playing a certain set of frequencies and not both of them playing the same. And the tweeter circuit probably is going to be this one, and this capacitor is going to be a high pass that chops off all the low frequency content from the tweeter circuit. I mentioned that a single capacitor is a 6 dB slope. So since you have two components in a circuit, that's going to be a 12 dB slope. Bear in mind that this crossover does not include a high pass for the woofer. Again, the high pass for the woofer is going to be either your amplifier, your head unit, or your DSP. This is just purely to blend the woofer and the tweeter. So basically this, the woofer plays lower frequencies, it chops off, and then the tweeter kind of picks up from there and plays all the higher frequencies. With a coax, you don't really have that, because the woofer, it plays naturally up as much as it can. It doesn't have a low pass filter. So with these, you can have a situation where both tweeter and this mid-range play the same frequencies and they're not blending as good. Exactly the same could be with the situation where you have this woofer with nothing and then you have a tweeter with a single cap. So yeah, but we're gonna see this from the measurements and I'm gonna explain everything in more detail using RTA. Now, if you're new to the channel, I do have a back to basics playlist where I explain everything that has to do with RTA, how to read RTA graphs, how to measure, how to use a microphone. If you don't know anything about that, you can watch that, because this video later on is going to be quite a bit more technical. Now, a lot of tweeted circuits will have some kind of a level adjustment or attenuation. So in this case, there's this little tab that connects to -2, 0 and +2. So +2 is not actually boosting anything. It should be ideally 0, -2 and -4, but it is done, I don't know really why. Most of the time the tweeter will have higher level. Think about this is the level in relation to the woofer, because if the woofer, for example, has a sensitivity of 90 dB and the tweeter has a sensitivity of 92 dB, it's already playing higher in level. So that's where those +2. If you leave it at 0, it kind of attenuates, and then both of them are going to be 90 and 90, and -2 is going to be 90 and 88. You can think about this in this way. Now, this level is achieved by resistors. You can have this resistor, and this resistor, because they're different values. You can see this is 1 ohm, this is 2 ohms, and this is 4 ohms. So it does this attenuation for you. Now, we will be playing with these just to see if we need to adjust it. I'm going to leave it at 0 for now, but later on, we will see from the RTA if we need more level, you can increase it on +2. If the tweeter is a bit too hot and it's too harsh, then we can decrease it to -2. Another thing is how to connect all of this, because these passive crossovers, they need quite a lot of wiring. So a lot of time people leave these passives inside the doors, which is not that great. However, most of the time is the only option, because if you want to have them outside of the doors, for example next to the amplifier or somewhere in the kicks, you need to run a separate wire for the tweeter circuit. So yeah, it's a bit more difficult. With these ones, you just connect this tweeter crossover, which is a cap, to this woofer, and you have everything inside the door. If you have a factory two-way in your front doors, it's going to be something like this, where you have a single cap. Just this cap, most of the time, is going to be fixed onto the tweeter. Now, these tweeters in this set, in both of these sets, they do come with two different options in mounting. So you have one option, which is like this. So you can either mount it like this on the dash, or like this flush on the pillar. Exactly the same goes with this one. You can see this, so you can mount it. Let me actually show you. inside the car, so it's going to be easier for you to understand what I'm talking about. So you can put them on the dash like this, and they're going to be facing towards you, kinda, or you can mount it on the pillar, and it's going to be something like this. Now my car has a factory two-way. Tweeter is going there, woofer is going there. We're going to take it apart, I'm going to show you, so I will not need any of these mounts. However, if you have a flat pillar, or you want to utilize your doors if you have somewhere a flat panel, which is not advisable, but a lot of people do that because they want to use the component tweeter and they don't have a space for it. So in this case, you have this flush mount where you can literally just drill a hole in the panel door and you just stick it in there, and it's gonna look kind of nice. So it has both for this tweeter and for this one. This one is a bit bigger, deeper tweeter, whereas that one is a bit more shallower. Yeah. So again, it depends how much space you have. Now, in regards to the frequency response, what can you expect from these drivers? If you take a manual for any kind of driver, you will have some specs. Most of the time it's going to be something like this. So it says for the components, this is the blue set, for the components, 45 to 20K. And for the coax, 60 to 20K. So the coax drivers, in this case, cannot play as low as the components. And in a lot of cases, it's going to be something like that. Because, as I mentioned, a coax driver is going to be a compromise for both the woofer and the tweets. Whereas with the component set, you can make them as good as you can for a certain budget, obviously. I know a lot of people are going to ask for power. Personally, I totally don't care about power. This set is what, 50 watts RMS, and this is 40 watts RMS, so a bit less, 10 watts here and there, but we can say they're very, very comparable. Now, another spec that is published here, you have here all the TS parameters for this. FS is 55, which is very low and very cool. QTS 0.5, you can have 0.6, 0.7, doesn't really matter. So what I'll show you is this Xmax, 3 millimeters of Xmax, which is a very little. Even if this driver, you can push it quite a lot, probably like 6-7 millimeters, the actual Xmax is the distance where the coil is inside the magnetic gap in there. So mechanically, these drivers can move much more, but without distortion being inside the magnetic gap, it's only 3 millimeters. And you can expect something similar to this. When I'm going to take apart my front door, I'm going to show you a woofer that has much more Xmax, but obviously it's going to cost much more as well. A lot of times for these, you don't have to be concerned at all because you will be crossing these drivers quite high. The crossover is going to be revisited in the next video. We're going to take objective measurements. We're going to take the distortion measurements and the frequency response on axis for the woofers and for the tweeters and for the coax separate. And again, as I mentioned in this video, I just want to break them in. I'm going to show you the RTA in the car, but all the other stuff is going to be later. I just took my front doors apart. This is the door card. This is this. If you want to see how this was done, how everything was deadened, I do have a separate video about door deadening, and another one, why is it so important. I do have these Museway aluminum rings in the front. I don't have anything in the back, as I mentioned, and these are the drivers. So this is the Illusion Audio C6 that I was running so far. It is a much more powerful driver that has much more Xmax. You can see the surround is much higher and all the motor is in the front rather than the back, but the size, let me just do this, is kind of the same. This is a bit more shallower. However, this driver costs probably like 10 or 20 times as more as that one. Yes, I do have a little bit of a rust. It was at the very, very bottom, so probably there was some water here from the very top because I didn't put any like water guard in there. So yeah, but this is just surface rust. It's gonna come off. It's not a problem at all. So now I'm gonna put these drivers. I just need some gasket because these come without any gasket, and you need gasket to have a proper seal between the door, the ring, and the speaker. Yeah, let me find some gasket, some bolts. I'm gonna bolt it in, and the tweeter is here. So let me just remove this very quickly. just like that. So this is the factory one, and as I mentioned, that's a tweeter, and this is the passive crossover, a single cap of 6.8 microfarads. So we're going to replace this one with the tweeter from the component set in this, because we're going to test it in factory locations. This is the gasket on the mid-range, mid-bass woofer. Very thin, like 1mm gasket, it's perfectly fine for that. This is the factory tweeter sale. You can see this. It's very bad, but I'm gonna use factory location so that I could show you how it looks like. So this is a factory tweeter. It just came off from there. This is the Recoil tweeter. What I did, I just took off the grill, because with the grill, you cannot put it in at all like that. I wanted to have as little gap as possible. So it is glued in, so you just literally just remove it, and then it fits flush like that. So I'm just gonna glue it in, again temporary, just for testing, because next week I'm gonna replace the tweeters for the yellow ones. But yeah, it's gonna look like this. This is not good. I'm expecting there's gonna be a cancellation in the very, very high frequencies when the sound is bouncing there inside. It's not gonna be 100% on axis as well, but we're gonna see that from the RTA. Hey, everything is installed. I just double checked that everything is working. Everything is working. I did manage to put the passive crossovers on this side, because that's the only place where I could. All this door panel is so close to the door card that the only places over there, you see that one, so that one is here. That's the only place that I could put. I put these wires just temporary. Again, I use some block connectors because next week all the speakers are going to be replaced anyway. For a temporary install, is going to be perfectly fine. So what I'm going to do now, very quickly, I do have a UMIC 2 measure microphone. I'm going to fire up REW. At the moment, it's from Helix and from the 5 channel. I didn't connect it yet. What I want to do now is, before I put the door cards back, I want to check the level of the tweeter, if you remember these clips. So I'm going to measure on +2, 0, -2, and I'm gonna choose whichever looks better on the RTA, whichever is the most smoothest. And after the selection, I'm just gonna put the door panel on, and then we're gonna measure everything with the door cards. So again, it's gonna be very interesting to see, because somebody asked me in the comments as well, what is the difference between when you measure with the door panel and without the door panel? Because this is sealed, there's no open areas that anything can go inside, so it should be kind of the same, but it's gonna be interesting to see. So let me take some measurements. Just very quickly want to show you the rear door. So aluminium ring, speaker, bolts, and everything is bolted like it's supposed to be. No gaps, no nothing. Yeah, those are the rear doors. Everything is installed. Rear doors coaxials, front doors components over there. This is hooked up as well. I did manage to put a breaker there. All the connections are made, so everything is fully functional, everything is fully working. So now I'm gonna jump in and make some measurements of all of these 4 speakers. However, I did have a listen to only the front, the components in the front, for like half an hour or so while I was driving. And I can say that without EQ, it's unlistenable. Now, we're going to see that in the measurements. Why? Because there's going to be probably, I'm guessing, quite a lot of peaks in the very nasty areas where everything sounds very harsh. But without EQ, as it is now, on passives in factory locations, and I cannot emphasize this enough, because the locations and the fact that it's passive causes that, it not necessarily mean that the speakers are rubbish. We're gonna find out in the upcoming future video when I'm gonna do objective measurements of those speakers. But for now, as it is now, like just literally swapping, putting in place, it sounds bad. It sounds really bad. It sounds very, very tinny. So the sound is hollow. It has a lot of energy in the lower mid-range, and it's very sizzly and shouty, so that's gonna be to do with the tweeters. I'm gonna show you the measurements. I just made a very, very quick tune, just tuned all of the speakers kind of flat, and oh my god, what a massive difference. So now I can understand why some people would say that, oh, cheap speakers are sound crap, because yes, if you just install them, put them like this, and have no processing, no DSP, no nothing, yes, it will sound crap, but with tuned correctly, it's such a huge difference. The only thing that I want to touch now is the rears, because what I did is I'm going to show you here as well very quickly. This is, the green is the front, both of the front speakers, and the red is both of the rear speakers. So they are playing at the same level. I didn't attenuate them. I left them because I wanted to see what it's like to have all the speakers playing at the same volume. And what's happening is that when you play only the fronts, the center is literally right there on top of the dash in front of you. When you play only the rears, the center image is somewhere here. Like you can hear, you can feel it from when you're sitting like this, you can feel it that it's in there. I did moved the time alignment. I added almost 3 milliseconds to that speaker, and you can feel how everything moves in there, but it stays down there. And when you play all four speakers, you still have a center image there, but it's like much more wider, and it comes, I think this is what people mean when they say they want a 3D sound stage and 3D image, where you have sound almost coming from all over the place, but with only time alignment on this side. So you basically delay this side so that the image goes in there, and you do exactly the same with the rear speakers. You still have the center there, but it's not precise. It's much bigger, much wider, and everything is coming kind of from all over the place. Now, it is probably like more immersive. Obviously, it's less accurate, so that is why I don't really like it. But maybe it's just an acquired taste. You need some time to spend with it. So I'm gonna spend like a week with all four speakers and just see how I adjust to it. Maybe I'm gonna like it. I don't know. But like, after the tuning, after EQ, it's like it's totally different speakers. It's not even comparable. All the harshness is gone, all the tinniness is gone, all the hollow sound is gone. It's just, it sounds like a normal set of speakers. So yes, you do need an EQ, you do need a DSP to make a cheap set of speakers sound good. While editing the video, I did realize that this video is already almost half an hour long. So I do apologize. I'm gonna cut it here because in the next video, when I want to show you all the measurements, there will be quite a lot of stuff to talk about. So I don't want one video to be an hour long. Hence, apologies, that's it for now. And in a few days, I'm going to release a video with all the measurements, and we're going to talk about the tuning as well.